at the next example. We have CH3, C, CH3, CH3. We have CH2 and another CH with a drop down CH3 and another CH2 and then the last CH3. So, how do we name this hydrocarbon? First, we check for the longest continuous chain, and that would be our parent chain. So, what is the longest continuous chain in this hydrocarbon chain? Looking at it critically, different students will take their counting differently, and as such, they will have different lengths as their parent chains. But if we are to look at it critically, we will get to observe that the longest chain, as you can see here, seem to be 6 carbon chains. 6 carbon chains seem to be the longest. Now let us see how to map it out again. Now student A may choose to take the straight chain. Student A may choose to take the straight chain. And taking the straight chain automatically will make this side chain 1, side chain 2, and side chain 3. This is for student A. Now for student B may choose to take his counting this way. CH3, CH2, CH, CH2, CH3. For student B, he may choose to go this way. Student B may choose to go another way, not by taking the straight chain. How can this next student choose to go? The next student may choose to go this way. Choosing, we have to, this is CH3. So, the next student may choose to go this way. So, we have it this way. So, you can see we also have 1, 2, 3, 4, 5, 6. So, we have side chain 1, side chain 2, and side chain 3. So, whichever way we choose to follow, we are still going to have the same naming. Either for student A or for student B, we're still going to have the same naming. So always use a pencil, dear students, to map out your parent chain. It makes it easier for you to identify which of these chains should be the parent chain and which is outside the parent chain and which is finally going to be our side chain. So let us consider taking the straight chain, that one for student A. And let's see how to name this compound. So, to name the compound, are we going to go through the left-hand side or come from the right-hand side? If we choose to come from the left-hand side, this will become carbon 1. Here we have carbon 2. Here is carbon 3. This will be 4. This will be 5. And this will be 6. But if we choose to come from the right-hand side, this will be 1. This will be 2. Here will be 3. This will be 4. This will be 5. And finally, this will be 6. So, if we are to go from the left-hand side, we have 2 side chains attached to the same carbon atom. So, since we are have agreed to go with student A, let us just make do with that and then erase this so that we can have clarity of explanations. So, looking at what we have on the screen displayed, if we are to go from the left-hand side, take the left-hand side in doing our numbering, 2 methyls, this one here and this other one here, they are both attached to the same carbon atom, and that is the carbon atom at 2 atom. Why? The 3rd methyl is attached to the 4th carbon atom. So automatically that will be, if we are to name that from the left-hand side, it is going to be 2, 2, 4 trimethyl hexane. This is coming from the left-hand side. We are to go from the left-hand side. That is left. Let's put it there, left. But let's now see if we are to come from the right-hand side, what will it be? Coming from the right-hand side, the first side chain there, methyl, will be attached to carbon 3. Is attached to carbon 3. Why? The 2 methyls that are attached to the same carbon atom will be attached to carbon 5. So automatically this will become 3, 5, 5 trimethyl hexane. So we can see that if we are to go by the rules, which says in naming a hydrocarbon, the side chain should be given the lowest possible number, that automatically disqualifies this second naming coming from the right. So taking our numbering from the left-hand side is the right option, and that will give us the compound whose name is 2,2,4 trimethyl hexane. 2,2,4 trimethyl hexane. So we have successfully learned how to take our counts when we have 2 or more side chains. The rule says that when we have 2 or more side chains that are of the same species, we use the words di, tri, tetra to actually denote their presence, and we have seen that here. As you can see, in this hydrocarbon here, we have 3 side chains that are of the same species, and they are all methyl species. So for that reason, we have identified their presence and also note where they fall under, the position where they fall under. And the positions where they fall under, 2 of the methyls actually fell under the same carbon atom. That is to say, they are attached to the same carbon atom, to the second carbon atom. That is why we have that name as 2,2. The 3rd methyl is attached to the 4th carbon atom, so we have it as 4. 2,2,4. Then we have it as to indicate how many they are. They are 3 methyl, so we have to give that name trimethyl, and we end the name of that hydrocarbon with the parent chain name, and the parent chain name is hexane because there are 6 carbon atoms there. The same thing also happens to our previous example, 2,3-dimethyl heptane. It is 2,3-dimethyl heptane because there are 2 methyl groups attached to that hydrocarbon chain, and that hydrocarbon chain has 7 carbon atoms which make up the parent chain. So that is why we indicate it as 2,3-dimethyl heptane.